Welcome everyone, I'm Adam. And in this problem, we're going to be verifying the identity square root of 1 plus sine theta divided by 1 minus sine theta is equal to 1 plus sine theta divided by the absolute value of cosine theta. Now when verifying the identities, what we want to do is show that one side of the equation is equal to the other. And again, the general rule of thumb is to take the more complicated side and work with that first. So this is kind of up to, or beauty being in the eye of the beholder, which is the more complicated side, the one with the square root or the one with the absolute value. But we do have kind of a guiding light as to kind of help us out here. If I see 1 plus sine theta in the numerator under the square root, and just a 1 plus sine theta in the numerator on the right-hand side, using what we know from algebra, if we take the square root of, say, something squared, we get that thing back again. So that's going to motivate me to take the left-hand side. So that's where we'll start. So we'll take the square root of 1 plus sine theta divided by 1 minus sine theta, and kind of ignoring this absolute value of cosine theta for a moment and just working on getting the numerator. 1 plus sine theta, we said if we take the square root of something squared, and we're going to develop that by multiplying underneath our square root. Going to multiply with 1 plus sine theta divided by 1 plus sine theta. So technically we're multiplying by 1, not really changing the expression, but our 1 plus sine theta times 1 plus sine theta is going to give us 1 plus sine theta squared. So as we said in the numerator, we'll have the quantity 1 plus sine theta quantity squared. And our denominator, two ways that we can handle this. We can FOIL it out, or if you remember from algebra, we have 1 minus sine theta times 1 plus sine theta. And there's a formula that says a minus b times a plus b is simply a difference of squares. And so looking at this as a minus b, right, and a plus b, so the denominator down here is going to be a squared, or 1 squared, which is 1, minus b squared, or sine squared. Okay, so now we said taking the square root of a square will give us 1 plus sine theta, but I'm not going to do that yet. We're going to hold off. And for reasons being that we're going to see in a couple of steps, where is this absolute value coming from? And it's going to have to do with that. So right now we're going to look at simplifying the denominator. We see 1 minus sine squared theta, which in the last section, that popped up a lot. Whenever we see 1 minus sine squared theta, or 1 minus cosine squared theta, what we ended up using was our Pythagorean identity, namely sine squared theta plus cosine squared theta equals 1. And with this implies that cosine squared theta is equal to 1 minus sine squared theta. So we can make that substitution. And again, for the time being, I'm going to leave the numerator as 1 plus sine theta squared, and the denominator can be written as cosine squared theta. Okay. So now we have the square root of 1 plus sine theta quantity squared divided by cosine squared. So looking at it, as we've been saying, taking the square root of a square, well, we know that's going to give us 1 plus sine theta. But if we take the square root of cosine squared, why don't we just get cosine theta? Where's this absolute value thing coming from? Well, there's an important thing from algebra that we have to remember when taking square roots of something squared. And namely, that is when we take the square root of something squared, that is equal to the absolute value of a say for all real numbers a. But we have, from this, taking the square root of something squared is equal to just the number if that number happens to be positive. So the way it works out is we have to look at these arguments not just being constants, right, but being functions that, depending on theta, could be possibly negative or could be possibly positive. And that's what we have to check. So if we look at 1 plus sine theta, or if we're here for a moment, think of it as a function, f of x equals 1 plus sine of x, and we look at the graph of that. We know that the graph of 1 plus sine x is just the graph of sine x shifted up 1 unit. So our graph is going to look something, what do we want to use? Like this. Now, what's important about that? We see that the graph of 1 plus sine of x does not go below the x-axis, or namely, this function is positive. And of course, if we look at the graph of cosine of x, right, we see that can be both positive and negative. So, coming back over here, when we're simplifying this square root, we look at the top part and see that this argument is positive. So when we take the square root of that thing squared, that's why we just get 1 plus sine theta. But taking the square root of cosine squared, using this over here, we know we need the absolute values. So there we go. The identity square root of 1 plus sine theta divided by 1 minus sine theta is verified to be 1 plus sine theta divided by the absolute value of cosine theta. Thank you very much.